Hi folks, on the software engineering side, let's try to do today this problem. This is Leetcode 1239, maximum length of a concatenated string with unique characters. So the problem here is that given an array of strings R, string S is a concatenation of subsequence of R which have unique characters. So before, and then he says that we need to return the maximum possible length of S. So basically find out the maximum length, the length of the max concatenated string. So you try to make a string by the concatenation of different words that are given to us in the input and try to get a string which have all unique characters, and what would be the maximum length of such a string. So that's the problem here. Now let us see the examples. Example 1 is input r equal to, is saying un iq ue, and what are all the possible combinations here. So if you take the set of all possible combinations, that would have to involve the empty set, because empty set is part of every set, and the uh, one each of these words that are given to us, and then all possible combinations of them. So if you take, for example, so he starts with this, he starts with un, and he starts with iq ue, and then he starts combining them. So uniq, which is all unique characters, and unue is discarded because u is repeated, and ique is perfectly fine because it also has all unique characters. So the maximum length is 4. Now I start the example 2. Here what you would see is that we will start with empty string and ch, so it will be ch, and ch and r will be char, and after that we would do chract, that is discarded because a is already repeated. Then cha, and r and ers cannot be there because r is common to those. So that means you got cha and ers, and then you got act and ers. And so the maximum possible length is the length of either of them, and that's 6. Then he gives another example, which is all the alphabets here as one string, which is A, B, C, D and all. So that goes up to 26, A to G. And what should be the output in this case? If you take empty string and this one, you basically combine them together, you concatenate them, you get this string, and there's only one such combination possible. And all the letters in that are basically unique. So the length is 26. And the constraints he gives us are we will not have more than 16 words, and then the number 2 is each of those, the length of each of the word is less than equal to 26, and that they all contain the lowercase English letters. So how do we go about solving this? This is not a very I wouldn't call it a low-hanging fruit. It's definitely a bit more involved. We have to really think what should be our strategy here. So one way to solve these kind of problems is, of course, first of all, we have to make sure that we understand the problem correctly. So it's not just the combinations of taking 2 at a time, but this could be any combination. You can 1 at a time, you can write 2 at a time, you can write 3 at a time, as long as you can make unique combinations. The letters should not be repeated. So if that is the case, how can we go about solving this problem? So What I read is that you could do something called there is a strategy in solving algorithms which is known as backtracking, which is kind of a DFS, depth first strategy. And a classic example of the backtracking strategy is N Queen's problem that was made popular by some German and French mathematicians or enthusiasts in 1800s, where they talk about how to place n queens on an n by n chessboard such that they do not block that all of them are valid legal moves. So for example, if you take 4 by 4 chessboard and you have 4 queens to put on this, so the brute force backtracking kind of a strategy is that you start by putting your queen on row 1 or row 0 if you want to be 0 based, and then go to the next row, and you, of course in the next row you have to make sure that you don't wherever in that next row, whichever column of the next row you put the queen, that, so maybe I should try to withdraw here. So what they say is that on a 4 by 4 board, so suppose if you have a board like this, and in this board, if you had to put a queen, what you do is the chess rules, following the rules of the chess, because as you know, the queen blocks on the same row or the same column or triangularly, or so we have to make sure that all the placements of the queen are legal placements. So you start by maybe starting on the first row, first column, and after that you would see that the second queen cannot be put either in the here or here, because that these are ruled out for the second queen. This is ruled out too, because then that means it can be pushed here. Now once you put it here, you will realize, by the way I forgot to make, okay, now once you put it here, you will realize that the third row we cannot put anywhere, because that this column is prohibited, this here we cannot put, this here we cannot put, in this. So that means this combination is discarded, and we go back to trying it by putting here, and then we repeat this experiment, and then you would see that it becomes some kind of a recursive depth first strategy where you try every possible combinations until you satisfy the constraint of the game, which is to put every row should have a queen, and none of those queens should actually block each other. So definitely worth checking out, I would say. I would definitely recommend you guys to check out the n queens problem, n queens classic backtracking classic problem. I would say classic problem that is solved by backtracking strategy. So we will use a similar approach, I would say, in theory. They may not look exactly same, but by the way, I'm still used to C style comments. So let's make sure that there is still Python. We are following the rules of the engagement here, which is Python. So we can use that strategy here too. So the way most of these problems are done is that, any recursive problem is done is that you have a base case, and then you have a case where you basically recurse, and the base case is how you get out of infinite loop, infinite recursion, I would say, because otherwise you will run out of this space on the stack. So definitely you do not want to get into infinite case. So let's see how we're going to do that. So I would start by one more thing we need to understand is that what should be our function prototype for recursion. So recursive function will be called, but what would be the arguments to it? One thing we can, let's say we call our function as max, or we call our function as unique, um, max unique, I would say, let's call it max unique uh, length. Let's just call it max unique length. And what would it take? So definitely it has to take array. That can be understood very easily, because what would it work on? So it would need the input, which is the array that they give us, and what is the next argument that possibly we can pass to it. So I'm assuming that the next argument could be that, hey, so other thing is that how are we going to make these concatenated strings? So usually what is done is that you make them as part of your argument to the recursive function rather than inside the recursive function. So in the beginning, that's going to be null. Then where in the array we would pick up the next string from. So we would take this value, which is the current string, which is of course right now nothing, and then the string at index in array, and we will kind of concatenate them and then try to see if it has unique characters. So that's one. And then we have, let us say, what would be the last argument? Now that is interesting here. Can we have an argument like this, result? So there are a couple of issues with that. One thing one needs to understand is that in Python, the arguments are passed by value. So if you pass just a result, like if you were to do something like int result equal to -1, then when this function returns, you say, after the function has returned, you say if result, if not result to -1, return result, else return minus, if not result equal to minus, else return -1. Let's say you do this. What is the problem with that approach? Because what would happen is the result would continue to have its value before the function was called. So just like in C, we can solve that problem by passing the pointers or reference to the thing that we want the callers to change. Oh, sorry, the called function to change. So in Python, we can circumvent that issue by actually having something like a list. So instead of passing, oh, by the way, I'm still not getting used to the Python's dynamic typing. It's still creating variables, names, and things like that. So result equal to, let's say it's -1. And I guess what I meant when I spoke too soon was that I meant like something like this. Suppose you had something like this, and then if you were to do something, okay, so then we can actually do the, yeah, I meant that if you had result equal to -1, and then if you say if result, and then you're hoping that we would this guy will change the value of the result, will be changed by the called functions, and then we can simply here could have just said return result. That's a strategy fraught with peril, because in Python the arguments are passed by value. So to circumvent that, we can pass a mutable like a list, and list will be passed by its reference, and that should be okay. So we can say result equal to -1, and then here what we do is we say if after the function is called, then we say that if not result 0 equal to -1, return result 0, right? Else result, or you can say here, you can say return -1 or something like that. So I would say that sounds like our def function, and this is our max length function. I'm sorry, that's our max length function, and now we have to code the max unique length function. So how, considering that that's going to be our prototype, so let's start coding the max unique length. So def max, so that is our def this function max unique length. First argument would be array, the next argument would be the current string, and then the next argument would be the index, and then the third argument would be a list of just one element where we would be storing our results. So what would that function do is that it would now this is basically a recursive call. This function is going to be recursive backtracking kind of strategy that we just spoke about. So I would definitely recommend you guys to do a Google for this n queens classic problem that is solved by backtracking strategy, and we'll use a similar here recursive call. So how do we do that? We say that we initialize a variable max length to 0, and then we call the max unique length again with the current str. So okay, so let's start combining. So if okay, so now we need a base case, by the way, this is recursion. So what would be our, if we are called and if we see that if index equal to the length of the array, then we know that we have considered all the elements and there's nothing more for us to, we have no more elements to walk through the array. We are at the end of the array, so we can basically return. And because you know this index should be going from r0 to the len r -1, and then if index is len r, that means we have gone. So if r has length 10, then the valid values for the index are 0 to 9. But if the index's value is 10, that means we have exhausted our array and then we can return. So that's our base case. And if that is not the case, then we continue our iteration, our recursion, which is if okay, so now what we do is we say let's walk from, for index in range. By the way, as you can see, we are going for len. So we are walking in the beginning, the index will be passed as 0, and the current string is a empty string, index is 0, and it is called here index. And if index, okay, so we will pass here for index in range, we'll go through the whole array here. So we have this for loop which is changing the index going from for each element in the array. So that is that. And then what we do is we say if now how do we check for the, so what we're going to do is, let's do here, let me write here. let's let's check for the uniqueness of characters in in um, char str. So we're going to do a concatenation now plus air index. So we will combine these two words and see if that's a unique thing, and if that is a unique, we will kind of follow the DFS, in the sense we will continue to, now we will basically do a recursive call with that new current string and then the next index. So how do we check that? Now in Python, is a very, being a very cute language, it gives us a lot of interesting primitives to do these kind of things quick. In any other language, you would have been doing things like maybe have an array and then keep a count of the each characters you see. You may have to write another function which checks for the uniqueness. But can we do that in one line in Python? How about using something like a set, the properties of set, to check for the uniqueness of characters in a combined concatenated string? So if we say if, so we throw the whole string, the combined string, to a set. So it says if length set, so now we are passing char str plus air index. If this length, so let's make sure all our brackets are matching up here. Okay, if this is equal to len, now list, now why are we making a list of the characters in the concatenated char str plus air index? So this is a very interesting thing that you would see why we are doing that. So now you see that this is actually our concatenated string. If you make a list, you get a list of characters. So let me just to explain to you a little bit here further. This is going to be like, imagine you had a string like concatenate. Suppose char str was leet, and the air index at that point was code. So this is this will become, that would become, so that would become something like, so Leetcode. So the whole thing would be char str plus the concatenated string would be, str would be Leetcode, and by, if you pass that to a list functions, a list of that, that becomes a list like this, L, and then you have E, and then if E comes again, that's fine, because we're doing a list, not a set, so there will be another E, and things like that. So here you would get, for example, in this case, you will end up getting 1, 2, 3, 4, 5, 6, 7, 8. So 8, that would be the length of on this side. And this side, because we're passing it to a set, what is set going to do is, it is going to eliminate all the duplicates. So you end up having, instead of 3 E's, you'll end up having only 1 E. So that means you will get rid of 2 characters. So 6, so that would be 6, this side will be 8, because 2 E's are gone, they're like duplicates. So that is how we can measure in a quick way. I can write a comment here saying set removes duplicates, if you guys are getting confused. So again, every time I do this, this happens. So and there's an interesting story here. I think in one of the classes that I did, they used to say that a guy goes to a doctor and then he says, doctor, doctor, it hurts when I do this. And then the doctor said, don't do it. So I guess that's what we need to do here. Don't do anything that basically messes the code. So if len set, so here we know that we have a we have a unique concatenated string. Concatenated string. So we have a unique concatenated string. Now let's try to make that. Now what do we do? Now that we have it, we need to recurse deeper now. In the sense, be greedy here. Get the next index now. So if that is the case, then before we go to the next step, we need to first see the length of this. So we say if. So maybe we should have written here concat str equal to, maybe it would have been even better to make that string over here, so that yeah, that might have been a much better strategy. How about if we had something like concat str equal to, and then we can say, instead of doing this, we can pass concat str to our set, and same thing here. Okay, so now if the length of the concat str, we know we have a unique thing. Now if len concat str is greater than max len, then we need to reset our max len to the new concatenated strings length. So that is looking good too. Now we'll have to make a greedy recursive call to consume more characters, more words in that array on its right side. So and then for that we have to pass the max unique length again with the new current, with the array as it is, but the new current str, or in this case which is concat str, and the index would be now index plus 1, and then we would be the result will remain as it is, because that's the list where we are filling in the first element of that. Okay, so here max len, I think we still have a bug, which is, if that is the case, if len concat str is greater than max len, actually that should have been the result 0. Then result 0 is set to the, I don't think we need a local variable max len here. That is going to be the result 0, because result 0 contains the so far the maximum unique string that we have seen by concatenation. So if len concat str greater than result 0 is reset to len concat str. We don't need this max len. And this is our base case. So it's all looking good so far. I can see that you guys are having fun so far. Max unique length air index plus 1, everything is looking good. Else, there's no else here actually. Else, unless you're doing some kind of debugging, you could have said we didn't get a unique string. So this loop, so the idea is now that we would keep consuming the, for example, if this were the array, what would have happened? We would have passed, we would have started with this, and then we would have said, okay, here in this loop, we would have said index is 0 in the beginning. So the 0 in this case, len ir would have been 3012. So we would take the current str, which is null empty string for air index. So that would have un. So we would have ended up with here concat str of un. Now un is has all the unique characters. So we would have, and then this length would have been greater than result 0, we set that point of -1, result 0 is set to 2. And then we would have passed it again here un and index plus 1. So that would have done uniq, and that way you see how we eliminate cases, or we go recurse deeper based on how we, as long as our condition of this condition keeps getting satisfied, we go deeper and deeper. Or we go, when it fails, then instead of going deeper, we actually go horizontal. So instead of going vertical, we start going horizontal when this condition fails. So that is the strategy at any point at the top level, and then at each of the branches in the at the top level. And those kind of this for loop would occur for considering this concat str would be changing whether it is the first time or the second time. So you would see that this for loop would be for that particular case, and it will run from then onwards to the remaining string. So you're going horizontal and vertical at any point in time until you hit index equal to len r. And good thing is that we don't have to say here 0 here. If we had said range len r, that means for every time we consider all the strings that we have seen before as well. But because the order is not important here in this case, we would only be considering strings of starting from left to right. So let's see if this passes our test cases. All right, we have a problem. We have a problem, and problem he's saying is you have a indentation error. And where was that? That was line 6. And I can see one more problem, that now that, so def, okay, I see here. I usually like this space indent of 4 spaces. I'm surprised that the editor they have here has not been alert and telling us to keep track of the indentation. So here, that's looking good. Now another problem I see here is that this is a member function, and I think he's going to complain about not having self, and here also he will complain about you calling a function that looks like as if it is a class variable or a static variable. So let's see now. Okay, max unique length is not defined. Okay, where's the problem now? Okay, that we can fix. We know how to fix that one. So self and all right. That was a victory that we were seeking in a very desperate manner, and we have succeeded. So we have to now see if we do a submit, will it pass all the test cases. And if the moment of reckoning has come and we have failed. We failed because he said we gave you input of y, and this, and you return -1. We should have returned 0. Let us see. So you see, if not result 0 equal to -1, then we return result 0. Otherwise we return -1. What if we had returned 0 here? I think it's coming because we are returning the wrong return value. But let's see again, submit. Awesome. That has been accepted by the Leetcode, and we are on our way to celebrating our success in this interesting coding exercise. I hope you guys had fun doing it. It's definitely a very interesting problem, because if you go and read this n queens classic problem that is solved by backtracking strategy in any computer science book or even just Google in general. By the way, I've always had problems accepting the term computer science, so my apologies if I use the word computer science, because I always thought the science was something that is things like physics and chemistry and biology, where you study the nature and you try to understand it. And I always equated the so-called computer science with mathematics and logic and algorithm. But that aside, philosophical debate aside, I would say that if you go and read this in any textbook, N Queen's classic problem that is solved by backtracking strategy, you would definitely find it extremely interesting. And this backtracking strategy is used in many class of there are certain types of problems that easily yield to this particular way of solving, and so definitely it makes sense to study about it. This is also seen, for example, when you have a path. Imagine you had in a graph algorithms, if you have to figure out the path from node A to node B. For that also they use this brute force backtracking strategy, and maybe it can be used to find the shortest path in a graph of n vertices with many different connections from between those vertices. So that is another area where this kind of algorithm is usually used. So I will leave you guys with those brainstorming thoughts, and I hope it was fun solving this problem with you. And I will see you guys in the next video. Until then, adios.